Hello everyone, welcome to Desperate MBA Prep. This is our third and final session of time, speed, and distance. In this session, we'll first look into escalators, and then we'll move on to the concept of races and tracks, and then we'll move on to the circular motion, and we'll solve some of the previous year CAT questions. Let's start with escalators. We all are aware of escalators, right? We can see escalators in shopping malls and in various places. So how can we relate the concept of escalators with the concept of time, speed, and distance? Let's see how. Let's say you are in this escalator, right? You are here, you are on this escalator. Now, the escalator is moving in this direction, right? So you are also moving in this direction. Now, when we compare the speeds of the escalator as well as your speed, as you are moving in the same direction, what is the relative speed? Relative speed is the speed of the escalator plus your speed, right? Why are we adding the speeds? Because when you are on the escalator and you are moving the same direction, then the escalator is adding some speed to you. It is helping you in reaching your destination, right? So that's the reason why we are summing up both the values. Take the other case. Now you are here, right? You are here, you are moving in this direction downwards, whereas the escalator is moving upwards. Then what happens in this case? What is the relative speed in this case? Relative speed is equal to your speed, or the speed of the escalator minus your speed, because both the directions are different, they are opposite to each other. So that's the reason why we are subtracting, right? But these two are in motion. In the first case, the escalator is in motion and you are also in motion, you are not in rest, right? And in the second case, both are moving. That's why we get this concept, relative velocity, relative speed. But what if the escalator is switched off? Then the total number of steps on the escalator when it is switched off is always constant, right? So in escalator concept, the total distance is measured by total steps taken, right? See, if you are here and you stepped 10 steps, right? You stepped 10 steps. Now what's the distance traveled by you? 10 steps. And at what speed you traveled, you finished these 10 steps? Let's say you finished one step for 1 second. So one step per 1 second, 10 steps will be 10 steps can be covered in 10 seconds. So this is your speed. So the distance is measured as steps, right? Counted as steps in escalators concept. So we have to remember this. Let's solve this problem. The speed of an escalator is 1 step per second. The speed of a girl is 3 steps per second. Now calculate the total number of steps in which the girl completes in 20 seconds when the escalator is moving in the same direction as with the goal. See, this session is a concept building session where we will also solve some problems, but most part of this session is purely concept building, because time, speed, distance is an area where CAT tests you. CAT puts some tricky concepts, right? It asks you to solve some different problems. It can ask you, definitely. This is unlike the other arithmetic topics which you find. So building concept in time, speed, and distance, in time and work is must. Building concept is not restricted to these two topics. You must do it for any topic, but these two are a must. So first build concepts, then we can solve different problems. Okay, the speed of escalator is 1 step per second, whereas the speed of girl is 3 steps per second, right? And is the direction same? Yes, the escalator is moving the same direction, right? This is the escalator, right? Escalator is moving in this direction, whereas the girl is moving in this direction. The direction is same. What's the speed of the escalator? Speed of the escalator is 1 step per second, whereas the speed of the girl is 3 steps per second. All right. So the relative speed, what is the relative speed? Should we add or subtract? We must add. So 1 plus 3, this is equal to 4 steps per second. So when the escalator and the girl do the work together, right, then the distance traveled by both of them in 1 second is 4 steps per second. That is the relative speed of both of them, right? So 4 steps per second is the speed, is relative speed. But the question is, calculate the number of steps in which the girl completes in 20 seconds. So if she covers 4 steps in a second, so in 20 seconds it can cover 20 into 4, that is 80 steps, right? Now, how did we arrive at this 80? How did we arrive? 80 is a combination of 60 steps plus 20 steps. 60 steps is for the girl, because the girl is completing 3 steps in a second. So in 20 seconds it must complete 60 steps. Whereas the escalator completes 1 step in a second. So in 20 seconds it must complete 20 steps. So 60 plus 20 is equal to 80 steps. So we arrived like this, right? Now, for instance, in this case, what if the escalator's direction is opposite to the girl's direction, or vice versa? See, let's see. This is the escalator's direction, right? 1 step ahead. Now the girl is not moving like this. Now it's not moving like this. Girl is moving in this way. Now if girl is moving in this direction, relative velocity now is 3 minus 1, because we must subtract as they are moving in opposite direction. That is equal to 2 steps per second, right? 2 steps per second. So the girl is moving 2 steps downwards for each second, not upwards. She is moving downwards, right? And the escalator is moving upwards. So in 20 seconds, the total steps taken are 20 into 3 minus 20 into 1. This is equal to 40 steps. So in 20 seconds, or we can directly multiply 20 into 2, right? So 40 steps. Now what happens if the escalator is switched off? Now if the escalator is switched off, the girl's speed is its original speed, right? 3 steps per second. So in 20 seconds, the girl completes 60 steps. So the first slide we discussed, right? When the escalator is switched off, the number of steps are constant, right? So understanding that concept in the escalators is important to solve some tricky questions, some difficult level questions. Now let's move on to races and tracks, where we will come across some different terminology. Let's look into them one by one. The first term is beating the distance. What does this mean? Let's say A beats B by 20 meters. Okay. So now let's assume A is here, right? This is the end point of the race, the finish line of the race. Okay. Now A beats B by 20 meters in a 100-meter race. So this is a 100-meter track, right? So A beats B by 20 meters. So what does this mean? A completes first. So B must be here by the time A completes the race. So B must be here. A must have finished the race, and the distance between A and B is 20 meters. This is the meaning of this. So beating by distance means this one. Okay. Now A beats B by 2 seconds in a 100-meter race. The same thing, but instead of distance, we have to take the time. So A beats B by 2 seconds means A must finish the race first. By the time A finishes the race first, B will be at a point of time, at some point of time. Let me erase this. So at some point of time, and from that time till the finish line, it will take 2 seconds to finish the race, right? So the time difference will be 2 seconds. The first case, the distance is 20 meters difference, but here the time difference is 2 seconds. That's just the basic difference between beating by distance and beating by time. Head start. So what's meant by head start? Let's say A gives B a head start of 20 meters. Let's take this. So this is a track. We have A over here and B here. So A gives B a head start of 20 meters. So 20 meters head start means A permits B to be ahead of some distance. In this case, 20 meters. So the difference of distance between A and B is 20 meters. So here A permits B to be ahead of some 20-meter distance. That means if B starts from here, A will start from here, right? B will start its race 20 meters ahead of A, right? Now what does A gives B a startup of 3 seconds mean? it's a startup of 3 seconds. What does this mean? Let's take the same track. Okay, so A is here, let's take B is here, and the difference between A and B, the time difference will be 3 seconds. That means, just imagine, see here, A and B will be at this time, at this point, right? This is A, this is B. Now B starts first, B starts and B goes, and B, after finishing 3 seconds, now A starts, right? So the speed may be different, the speed of A and B can be different, they will be different for sure, right? B starts first, and after 3 seconds of the start of B, A starts the race. This is the meaning of A gives B a startup of 3 seconds, right? Dead heat. A and B finish the race in a dead heat. What does this mean? See, let's say A and B can start at any place at any time. That doesn't matter. Let's take a track here. This is a track. Now A can start from here, B can start from here, or A and B both can start at the same point. That doesn't mean, right? No issues at all. But the end line, the finish line, see, they will finish the race at same time. They can start at any point of, they can start the race at any point of time, at any time, not a problem, but they will finish the race at the same time. Dead heat means finishing the race at the same time. Both of them reach the finish line at the same time, right? Now let's solve this. A can beat B by 200 meters in a 1 kilometer race, and B can beat C by 100 meters in a 1 kilometer race. By what distance will A beat C in a 2 kilometer race if both run the 2 kilometer race at the same respective speeds they run the 1 kilometer race? Okay, see here, please remember, in races, time is always constant. Please remember this, time is always constant. Now let's solve this. This is a track. Now A and B start here. A starts from here and B starts from here, right? Same point. Now what's the question? The question says that A can beat B by 200 meters in a 1 kilometer race. If we assume this one to be 1 kilometer, the track to be 1 kilometer, A beats B by 200 meters. So if A is here, right? If A completes 1000 meters, that is 1 kilometer, B must have 800 meters, right? So B must be here, A must be here, and the difference between these two, the distance is 200 meters difference. So here we know that time is constant in the concept of races. A and B take the same time, but A completes 1 kilometer, but for the same time B completes 800 meters. Now as time is constant, we can say that speed of A by speed of B is equal to distance covered by A by distance covered by B. We know distance covered by A is 1000 meters and distance covered by B is 800 meters, right? What is the ratio here? 10 by 8. So the ratio of speed of A and speed of B is 10 by 8. We can also further simplify. Let's keep this aside. And in second case, what is given? B can beat C by 100 meters in a 1 kilometer race. So what is speed of B by speed of C is equal to, B can beat C by 100 meters. So B travels 1000 meters. So by the time B travels 1000, C travels 900 meters, right? Because B can beat C by 100 meters. So difference is 100 meters. So the ratio is 10 by 9. The ratio of B and C is 10 by 9. The speeds of B and C is 10 by 9. Now we know the ratio of A and B. We also know the ratio of B and C. What must we find? We must find the ratio of A and C, right? A and C. So let me erase this. So speed of A is to speed of B is equal to 10 is to 8. Whereas speed of B is to speed of C is 10 is to 9, right? We must find out speed of A and speed of C. Now speed of A is to speed of C is equal to speed of A. What is speed of A? 10 into 10, that is 100, right? Now speed of C is 8 into 9, that's 72, right? Now if both run the 2 kilometer race at the same respective speeds, see, if it is a 2 kilometer race, then we must multiply 100 with 20. So then only it becomes a 2 kilometer race. So if we multiply this one with 20, we must also multiply 72 with 20, right? So 100, initially the difference between 100 and 72 is, what is the difference? Sorry, we have to take ratio here. Okay, So what's the difference of between 100 and 172? 172 is 28, right? 28 meters. So if we multiply 100 with 20, we must also multiply 72 with 20, and we must also multiply 28 with 20. So now it becomes 560 meters. Understood? So by 560 meters, A beats C in a 2 kilometer race if both run the 2 kilometer race at the same respective speeds, right? Let's move on to the next one. In a 200 meters race, A beats B by 100 meters or 2 seconds. Find the speed of B and A. Okay. See here, this is a 200-meter race, right? 200 meters race. This is the track. Okay. Now, A beats B by 10 meters. That means by the time A finishes the race, B must be somewhere here, right? Behind A, right? So A must be here, B must be here, somewhere here. And the distance between A and B must be 10 meters. The difference is 10 meters or 2 seconds. It's given, right? 10 meters or 2 seconds. 10 meters is equal to 2 seconds. Now this helps us in finding out the speed of B in a quick way. So speed of B is equal to the distance by time. So distance is 10 meters and time is 2 seconds. This is equal to 5 meter per second. So 5 meters per second is the speed of B. What about the second one, speed of A? See, we know that time is constant in races, right? In all the problems of races, time should be constant. Time is constant. So as time is constant, the speed of B by speed of A is equal to distance traveled by B by distance traveled by A. What is speed of B here? Speed of B we know 5 meter per second. What is distance traveled by B? It's 190 meters. Why 190? The track is of 200 meters and B is 10 meters behind A. That means B must have traveled 190 meters by the time A finishes the line, right? Finishes the race. Now total distance traveled by A is 200 meters. Now the speed of A, calculate. The speed of A will be 100 by 19 meter per second. Let's move to the next one. In a race of 3 horses, the first beat the second by 11 meters and the third by 90 meters. If the second beat the third by 80 meters, what was the length in meters of the race course? Okay. So this is the previous cat problem. Okay. Now, what is the question saying? This is a track. Okay, this is a race. Okay. The first horse, there are 3 horses. In a race of 3 horses, the first bet the second by 11 meters and the third by 90 meters. If the second bet the third by 80 meters, what was the length in meters of the race course? Okay. Now, what's the question saying? There is a race, okay, and there are 3 horses. The first bet the second by 11 meters. That means by the time horse 1 finishes the race, this is the end of the race, right? So finishes the race, horse 2 must be somewhere here, okay, and the difference between horse 1 and horse 2, the distance is this one, is 11 meters, and the third by 90 meters. Okay, so the first one bet second horse by 11 meters and the first one bet third horse by 90 meters. Now if the second bet the third horse by 80 meters, what was the length? Okay, so second bet third horse by 80 meters. So what does this mean? By the time the second horse reaches the end line, finishes the race, horse 3 from here will slightly move forward, right? And the difference now between horse 2 and horse 3 must be 80 meters. See, understood? Horse 2 beats horse 3 by 80 meters. What does this mean? Horse 2 first must complete race to finish the race, right? It must first finish the race. By the time it finishes the race, the horse 3 also slightly moves forward, and the difference at that point till the horse 3, the difference between horse 2 and horse 3 is 80 meters. Now we know our time is constant, right? If we carefully observe, horse 3 travels 10 meters by the time horse 2 finishes the race. So as time is constant, we can say that speed of horse 2 by speed of horse 3 is equal to the distance. How much did horse 2 complete? So the distance traveled by horse 2 is from this point to the finish line, the end line, which is 11 meters, and the distance traveled by horse 3 is 10 meters. So meter and meter get cancelled. So 11 by 10, so the difference of between 11 and 10, difference of 11 and 10 is 1. So the second horse bet the third horse by 80 meters. So this is 80 and this one is also 80. So if it bet by 80 meters, now the total distance of the total length of the track is 80 into 11, which is 880 meters. 880 meters. See, we already got the speed, the ratio of speeds, which is 11 by 10, right? So 80 is the meter. So speed into time, that is equal to distance, which is 880 meters. So the total length of the track in meters is 880. Circular motion, very important concept. Please understand carefully. It's better to take some cases and delve into this concept. So the first one is distance calculation, distance and time calculation in circular motion. Here we have A and B are on a circular track of length 250 meters, whereas speed of A is 30 meter per second and that of B is 20 meter per second. They both start moving from the same point in opposite directions. So if A runs in a clockwise direction, how far from the starting point in the clockwise direction will they meet for the first time, for the second time, for the nth time? Okay, so let us say here, this point. So A is here and B is also here, right? And what is the circumference given? The circular track of length 250 meters. Okay, so the track is 250 meters. So 250 meters is the circumference. One important thing here to note is opposite direction. A and B are traveling in opposite directions. That means A's speed is 30 meter per second, right? So it is in this direction, let us say 30 meter per second, and B should be in this direction if A is in that direction. So B's speed is 20 meter per second. Now as both are in motion, what is the concept that we must think of? We must think of relative speed, right? So relative speed comes here. And what is the relative speed now? They are moving in opposite direction in circular tracks. What is the relative speed? When they are moving in opposite, when two bodies move in opposite direction, should we add the speeds or should we subtract the speeds? We must add those speeds, because it's like the train concept. In train concept, if two trains approach each other, if two trains move towards each other, then we add the speeds of the trains. In the same way in circular track, when two bodies move in opposite direction, the work done, the distance covered, the speed gets added, right? So here the time is equal to distance by speed, we know that. So this will be, distance is 250 meters, the total length of the track, and speed is relative speed. 30 plus 20, this is equal to 50. So 250 by 50 is equal to 5 seconds. So they will meet for the first time after 5 seconds. Understood? Now in this calculation, as we discussed in our second session of time, speed and distance, whenever we calculate relative speed, right, in relative speed problems, we can assume the speed of this the slower body, in this case B, right? Slower body, we can assume that to be constant, to be stationary. Now if B is stationary, A must travel 250 meters. In order to nullify that, we'll take relative speed in the denominator. So 30 plus 20, this will be equal to 50, right? So 5 seconds is the answer. But here this is the time calculation, but what about distance? In 5 seconds, A must have traveled 5 into 30, this is equal to 150 meters. Why? Because the speed of A is 30 meter per second and the distance, the time, total time is 5 seconds. So 5 into 30 is 150 meters, that is covered by A. What about second time? See, for the second time also, the time taken will be 5 seconds, right? It won't be more than 5, it won't be less than 5, because the speed is constant. A speed is 30 in second case and 20, B speed is 20 in second case. There is no change in speed, there is no change in the length of the track. So the time won't get changed. So the time will be 5 plus 5. The first one is 5, second one is and one more 5 seconds. So time is 10 seconds. So they will meet for the second time after 10 seconds, right? And how can we calculate distance here? See, the distance traveled here is, for the second time, is 300 meters, right? Now if we divide 300 meters with the length of the track, that is 250 meters, the remainder will be 50 meters. This is the remainder. Now how far from the starting point in the direction will they meet for the second time is 50 meters. So this is the starting point, right? This is the starting point. Let's say this here, this is 50 meters. The distance between the starting point and the second meet is 50 meters. So this one is 50 meters, right? Now what about nth time? Nth time, the time is n into 5 seconds. N into 5 seconds. That is n into first time, right? In this case, it's 5 seconds. What about distance? Distance is also same, n into 150. 150 is the first time distance, right? By the length of the track. In this case, it's 250 meters. So n into distance covered by the length of the track will give us for the nth time, in which the distance between the nth meeting and the starting point, right? So n into 150 by 250. Now the remainder, yes, this remainder tells us how far in the final lap B is, right? So that remainder we get tells us how far in the final lap this guy is. Now this 50 meters will tell us in the final lap how far B would have gone. See, from here to again till here, this will be 250 meters, right? From here to here, this is 50 meters. So this is one lap. This is the final lap. In the final lap, B would have gone 50 meters. This is what it's all about. And for the nth time also, if we calculate this, the remainder we get, that remainder tells us how far this guy is completing in the final lap. So this is how we calculate distance and time in case of circular track, right? So distinct meeting points. A and B are on a circular track of length 250 meters. Speed of A is 30 meters per second and that of B is 20 meters per second. So they both start moving from the same point in opposite directions. So at how many distinct points on the track do they meet? So the values are same as the previous one, and we calculated for the first time the distance is 5 seconds into 30 meter per second, and this will be equal to 150 meters, right? See, this one is A, this one is B here. A is moving in this direction, that is 30 meter per second, whereas B is in this direction and this is traveling at a speed of 20 meter per second. The question actually says that from here to here, let's say this one from the starting point, right, that is from here, this from starting point to here, this is 150 meters. So this is the first distinct point that they meet, right? Now the second one is from here to 150 meters. That means from here to here. So this will be the second meeting point, right? Then where is the third meeting point? From second meeting point plus one more 150 meters. So this will be around here. This is the third meeting point, right? The fourth meeting point will be from here to one more 50 minutes, one more 150 meters. This will be around from here to here, it's 50. From here to here, this is 100. So this will be fourth meeting point, right? Then where is the fifth meeting point? From here to one more 150 meters. So from here to here, so this will be 50 meters, and from here to here this will be 150 meters. So again they reach the starting point. So this is the fifth meeting point. Now if we calculate like this, how many distinct points on the track do they meet? There are 5 distinct points, but it's not a very convenient way to calculate this in exams. If it is 250 meters or lesser than this, we may calculate, but it's somewhat time consuming. What if we are asked to calculate for more length, greater length than 250 meters? It's not advisable to count like this. So what must we do in this case? In these kind of cases, we must take the ratio of speeds, right? Ratio of speeds. Here we got 5 distinct points by calculating by through our calculation. But if we take this ratio of speeds of A and B, A is to B is equal to, what is the ratio here? 30 is to 20, right? 3 is to 2. This is the ratio. Now we have two cases. Opposite direction is case 1 and same direction is case 2. Same direction. Now in opposite direction, as we know, we have to add the speeds, right? So 3 plus 2 is 5. We got here, right? This 5 and this 5. These two are same. And in same direction, what must we do? We must subtract 3 minus 2, that is 1. So if A and B had traveled in same direction, they would have met at only one distinct point, whereas A and B now traveled in both in opposite directions. So the distinct points, total distinct points are 5, right? So instead of calculating like this, we can simply take the ratios and we can add in case of opposite direction, we can subtract in case of same direction. Hope you understood. Let's move on to this. A, B, C run on a circular track of 800 meters. Speeds of A, B and C are 20 meters per second, 26 meter per second and 33 meter per second. Okay. So what will, when will they meet for the first time, and what is the ratio of distances covered by each one to meet for the first time? Alright. So this is a question where more than two are involved in a track, circular track, right? So what should we do? So in the first case, we are asked to find out to calculate the time. So time, we know time is equal to distance by speed. That's the general formula. So time taken by C to meet A for the first time. How can we calculate that? Distance. What is the distance here? 800 by, what is the speed? Relative speed. 33 minus 20, right? So this will be 800 by 13 seconds. Now time taken by C to meet B, this is time taken by C to meet A. Now in the second case, we must calculate time taken by C to meet B for the first time. How can we calculate? Distance by, distance is 800 by speed, relative speed, that is 33 minus 26, this will be equal to 800 by 7 seconds. So time taken by C to meet B for the first time is 800 by 7 seconds. Now in order to calculate when all the three meet for the first time, in order to calculate the time, we must take the LCM. We must take the LCM of this one and this one. If we observe these are fractions. How can we take LCM in fractions? I mean in case of fractions, we know, right? LCM of fraction is equal to the LCM of the numerator by the HCF of the denominator, right? So in this case, the LCM of the numerator is 800 and 800. So this will be the 800, and HCF of denominator 13 and 7. This will be HCF is 1. So 800 is what is the unit? 800 seconds. So 800 seconds means 13 minutes and 20 seconds, right? So if we divide this by 60, we'll get 13 minutes and 20 seconds. So all the three, A, B and C, meet after 13 minutes and 20 seconds. So in order to calculate time, first take the LCM, then we get the value which is time. So after they meeting the first time, right, when we have to calculate after what time they will meet for the first time, we have to take the LCM. Now what is the ratio of distances covered by each one to meet for the first time? Ratio of distances, we know ratio of distance is equal to ratio of speeds, right? So in second case, the ratio of distance covered is equal to 20 is to 26 is to 33, which is the ratio of speeds. So now we have completed the time, speed and distance, all the concepts. We'll move on to the advanced phase of arithmetic, where we solve all the problems related to arithmetic topics, right, from percentages till the time, speed and distance. Okay, See, all the topics, all the concepts that we have discussed in this session are, they're productive. We have to think about them. We have to practice some different models in order to get accustomed, so that these concepts stick to our mind. And we have to take, after finishing some part, we have to take some sectional mocks. It can be CAT, it can be any exam, but in especially CAT, we have to take sectional mocks instead of full length mocks. It can be VARs, it can be quant, it can be LRDI. But sectional mocks are important. After that, we can take the full length mocks, right? So 40 minutes. The questions, the expected number of questions are around 22, more or less 22 questions in quant. So take sectional mocks, get accustomed to the new time duration, new number of questions, right? The reduced number of questions. So anyways, arithmetic is definitely like, it plays a crucial role in quant. So it also helps in DI. Of course, CAT DI is more of logic than calculation. Anyways, arithmetic helps in DI. So be comfortable with DI, with arithmetic, so that it can fetch you a good percentile, not only in CAT but in other non-CAT exams. But because soon after CAT, we all move on to non-CAT, right? Practice well. We have enough time. We have still we have time. No worries. So still we have time. Practice well. All the very best. And in case you haven't subscribed our channel, subscribe it. And you can also join our Telegram group. The link is provided in the description. Thank you.